Have you ever just looked up at the night sky and wondered, where did all of this come from? I mean, not just the stars and the galaxies, but everything, space itself, time itself. Well, today, that's exactly the question we're diving into, the story of our universe. I mean, this is the ultimate origin story, right? We're not just talking about the start of humanity or our planet, but the beginning of everything that exists. So how do you even begin to answer a question that massive? Okay, let's dive in. We're going to start with the most fundamental concept in all of cosmology. It's an idea you've definitely heard of, but trust me, it is almost always misunderstood. The Big Bang Theory. This is our best scientific explanation for how it all started. The core idea is that about 13.8 billion years ago, all the matter and energy in the universe was compressed into a single, infinitely small, hot, dense point. And from that point, it all began. But, and this is a big but, not in the way you might be picturing it. Now, this right here is the number one thing people get wrong. The Big Bang wasn't a bomb going off in space. It was the rapid expansion of space itself, everywhere, all at once. See, there was no outside for it to explode into. Space and time literally began with this expansion. That's a huge difference. And this whole process kicked off an immense amount of time ago. We're talking 13.8 billion years. It's a number so vast, it's kind of hard for our brains to really comprehend. But every single event we're about to discuss fits right inside that cosmic calendar. So, how did we get from that tiny, hot, dense point to the sprawling cosmos we see today? Let's walk through the key moments. You can think of them as the universe's baby pictures. The first moments were unbelievably dramatic. In a tiny fraction of a second, a process called inflation caused the universe to expand faster than the speed of light. Then, within the first 3 minutes, things cooled down just enough for the very first elements, hydrogen and helium, to form. For the next 380,000 years, the universe was this hot, dense fog. But then, it cooled enough for light to travel freely for the very first time. Finally, after hundreds of millions of years, gravity started to work its magic, pulling that hydrogen and helium together and igniting the very first stars. And that first light is incredibly important. We can actually still see it today. It's called the cosmic microwave background, or CMB. Think of it as the oldest light in the universe, a faint, cold afterglow from the dawn of time. Looking at it is like looking at a fossil of the universe when it was just an infant. Absolutely amazing. But the story doesn't end there, not even close. As we learned more, we started to realize the universe is far, far stranger than we ever imagined. The stuff we can actually see, turns out it's only a tiny fraction of what's really out there. So here's a puzzle. When astronomers looked at galaxies, they saw them spinning so fast that honestly, they should have just flown apart. The gravity from all the visible stars and gas just wasn't strong enough to hold them together. So, what was the extra gravitational glue? Well, the answer seems to be dark matter. It's this mysterious, invisible substance that doesn't interact with light at all, but it has mass. And because of that, it has gravity. It acts like an invisible scaffolding for the cosmos, providing all that extra gravity needed to hold entire galaxies together. As if one giant cosmic mystery wasn't enough, another one popped up. Scientists had always assumed that gravity would be slowly putting the brakes on the expansion of the universe. Makes sense, right? But when they actually checked, they found the exact opposite was happening. The expansion is accelerating. Something is pushing everything apart. We call this mysterious force dark energy. It's like a kind of anti-gravity, a repulsive energy woven into the very fabric of space-time itself. And right now, it's the dominant force in the universe, pushing galaxies away from each other at an ever-increasing rate. And this slide really puts it all in perspective. It's kind of mind-blowing. If you take everything we can see and touch, every star, every planet, every person, it all adds up to only 5% of the universe. The other 95% is made of these two dark mysteries, dark matter and dark energy. We live in a cosmos dominated by substances we can't see and don't yet understand. So after all this mind-bending cosmology, you might be asking yourself, okay, but why does any of this matter to me here on Earth? Well, the answer is, it matters profoundly. You know, studying the universe's origin isn't just an abstract exercise. It's how we discovered that all the heavier elements needed for planets and life were forged inside stars. It underpins our understanding of how our own solar system came to be, and the pursuit of this knowledge pushes our technology to its absolute limits, leading to innovations from better satellites to new materials. But here's the best part. The story of the universe is our story. The iron in your blood, the calcium in your bones, the oxygen you breathe, every single one of those atoms was created in the fiery core of a star that lived and died long before our sun was even born. We are, quite literally, made of stardust. We've journeyed from a single point to a universe filled with dark secrets. But the story isn't over, not by a long shot. Scientists are now peering over the edge of what we know, into the realm of what might be. Some of the most advanced speculative theories in physics suggest that maybe the Big Bang wasn't a one-time event. They propose that our universe could just be one bubble in an endless cosmic ocean, a multiverse, where other universes are constantly being born, maybe even with different laws of physics. It's a mind-bending idea, and it's right on the frontiers of science. And so we're left here. We've traced the journey from an infinitely small beginning to the vast, accelerating universe we inhabit today. A universe that is mostly unknown to us. From one tiny point came everything. The ultimate question that remains is, what happens next?